Hello everyone. In this video, we will do more examples for improper integrals over negative infinity to infinity interval. So in these examples, always we separate integral into two pieces. From negative infinity to any number you like, I'll put 0. And then from the same number here, 0 up to plus infinity, yes? So we have to integrate both of them. But to integrate either to check the divergence of each one, we need to know what is antiderivative of x e to the power x dx. This we can find using integration by parts. This will give me x e to the power x minus integral of e to the power x dx, which will be x e to the power x minus e to the power x plus c. But I can factor out and get this one. So I have that antiderivative there. Why I need that? Because now I replace negative infinity by 0 and then try to find this definite integral. So this will be x minus 1 e to the power x, go from t to 0. And then you plug it in there. So this will be 0 minus 1 e to the power 0 minus t minus 1 e to the power t. Which is what? Which is, let me just write it here. X e to the power x dx is going to be minus 1 plus t minus 1 e to the power t. Now, we find the limit of this as t goes to negative infinity. And what we notice here is that, okay, this will be negative infinity, this piece, e to the power negative infinity. Remember the graph, e to the power t, as t goes to negative infinity, that is 0. So infinity times 0. So I have to deal with this situation. But I can do it by just, by the way, the negative sign, negative 1 is constant there. Then I can do like this, t minus 1. And write e to the power t as e to the power negative, 1 over e to the power negative t. As t goes to negative. Now, if you check, this is infinity over infinity. And we can use Labtube's rule. And this will give negative 1 plus, well, limit of the numerator is 1 over e to the power negative t as t goes to negative infinity. As t goes to negative infinity, e to the power negative t goes to plus infinity. So 1 over e to the power negative t is going to be just 0. So this way, we showed that the first integral is convergent. We cannot say anything yet because we have to check the second one. The same kind of work goes on the second one. And we get t minus 1 e to the power t minus negative 1, which is plus 1. Yes. And then when we find the limit of 0 to t x e to the power x dx as t goes to plus infinity, this is the same thing as limit of t minus 1 e to the power t plus 1 as t goes to plus infinity. See, t minus 1 as t goes to plus infinity times e to the power t as t goes to plus infinity. So two big positive numbers multiply, you get positive number, and that will be positive infinity. What does it mean? It means that the limit does not exist, and as a result, this limit is divergent. The integral is divergent. So one of two integrals were divergent. That means that the whole thing is divergent. So we don't have any number for that. Okay. So another example, find the area of the region under the graph of this point. If you check the graph of, it's interesting to see the graph of this guy has something like it's something like that. And while we are interested in finding the area of the region under the graph of this guy, which means that, okay, first look, you see that, okay, this seems very huge, but we have to check, see if it is convergent or not. First, let me just find antiderivative of this guy here. This is going to be tan inverse of x, yes, plus c. And then on the other hand, we want to find the volume. Sorry, I should have written this one first. From negative infinity to plus infinity of 1 over x squared plus 1 dx. This is improper integral with two infinities, so we have to separate it in two pieces. One going from, say, 0 to plus infinity. The other one goes from negative infinity to 0. And while to evaluate those ones, we replace negative infinity by t. Find that, so this is tan inverse of x, go from t to 0. And that is tan inverse of 0, which is 0 minus tan inverse of t. Then we find limit of t to 0, integral from t to 0 of 1 over x squared plus 1 dx as t goes to negative infinity. This is negative tan inverse of t as t goes to negative infinity. Oops. So here what we are interested in, then we wanted to see what is limit of tan inverse t as t goes to plus infinity. Here it's good to have the graph of tan inverse. Graph of tan inverse, you should keep in mind this graph. It has two horizontal asymptote, one at negative pi over 2, the other one at pi over 2. But when t goes to negative infinity, it goes to negative pi over 2, yes? There is a negative there also, so this will be just pi over 2. So yes, this guy is convergent and its value is pi over 2. Yes, from here. But we are not done. We have to see what happens for the other one. Okay, for the other one, the same story goes. We replaced infinity by t. That would be tan inverse of t minus tan inverse of 0, which is 0. Then find limit of integral as t goes to plus infinity. This is the limit of tan inverse of t as t goes to plus infinity. As t goes to plus infinity, look at the graph. This goes to pi over 2. Okay. This one is also convergent. And its value is pi over 2 as well. Now that both of them are convergent, then I can say that this guy is convergent, the original one. And its value is equal to the value of the sum of the values of these two integrals. So pi over 2 plus pi over 2, which is equal to pi. So this integral, there's a region down there. It is expanded along an infinite region, infinite length, but the region has finite area, which is pi. Okay. So these were two examples that we wanted to do for these cases. So you have to be able to remember that, first of all, you have to separate these two cases, negative infinity part, plus infinity part, and then go from there and find it. Both of them, if both of them are convergent, add them. That's the value of the total integral.